Lesson 7-1, Understand Likelihood and Probability. In this lesson, we're going to learn how to describe the likelihood that an event will occur. First, take a look at the Solve and Discuss It question. For a game show, Jared has to choose one of 8 boxes to win a prize. One of the boxes has a big prize, 3 boxes have a medium prize, 3 boxes have smaller prizes, and 1 box is empty. How confident should Jared be that whatever box he chooses, he will win a prize? Support your response with a mathematical argument. Work on this problem now, and then come back and let's discuss some possible answers. In this problem, remember only 1 box is empty. The other 7 boxes have a prize in them. Some prizes are small, some are medium, and 1 is a big prize. But the problem only states how confident should Jared be that whatever box he chooses, he will win a prize. So we need to consider all the boxes that have a prize in them, and there are 7 of them, which means Jared has a 7/8 chance. 7 out of 8 is the same as 87 5/10%. He has that big of a chance of getting a prize, so he should be confident. Now let's take a look at some other problems and discuss how likely they are to occur. Now read example 1. In this example, we're going to use probability to describe chance. Elisa and Sherry spin the pointer to the right and record the color that it lands on. The table shows their results after 100 spins. How can Elisa and Sherry explain their results? There are 4 possible outcomes or results when Elisa and Sherry spin the pointer. It can either land on red, yellow, green, or blue. Notice that each section is the same size and there is 1 section of each color. This makes it a fair spinner. The reason it's fair is it means that each of the 4 outcomes is equally likely to occur because the pointer has an equal chance of landing on any of those 4 sections. Each time they spin the pointer, the likelihood or the probability of the pointer landing on red, yellow, green, or blue is the same. Each of the equal-sized sections is shaded one of those 4 colors, so the probability of the pointer landing on any given color is 1 out of 4, or 1/4. And since 1/4 is equal to 25%, the probability can also be written in a percentage form. Remember, as a reminder, to change your fraction into a percent, like 1/4, that means 1 divided by 4, which gives you a decimal, and then to change that decimal into a percent means multiply by 100. Now go down to the try it question at the bottom of the page. Try that question looking at a new spinner and see if you can answer the question. Some things to consider for the try it question are to look at how many sections are now on the spinner. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 sections now instead of 4 as there were in the example. How many sections of each color do you have? And that answer is 2 sections of each color. So that means we have 2 red sections, 2 yellow sections, 2 green sections, and 2 blue sections. So the probability of the pointer landing on a given color is now going to be 2 out of 8, which is the same as 1/4 or 25%. So the probability in this problem does not change because the fraction that names the chance of getting any of those 4 colors is the same. Now look at the convince me. How would the probability of the pointer landing on a given color change if the spinner had 6 equal-sized sections with each section a different color? Well, in this case, if we have each section a different color, then there is one section of each color and 6 sections total. So the probability for any of those colors would be 1 out of 6, which is, do you know what that is as a percentage? Find out by doing that division and then come back and check your answer. That makes it about 16 7/10%. Okay, that is rounded because 1/6 as a decimal is an approximation because it's repeating. Now let's look at example 2. Use probability and likelihood to describe situations. Carrie will roll a number cube with sides labeled 1 to 6. A. What is the probability that she will roll a 2? Well, if you look at a number cube and each side is labeled from 1 to 6, that means there is a number 1, 2, 3, 4, 5, and 6 on each side. Since there's only one side that has a number 2 on it, that's 1 out of 6, the probability is 1/6. Now, sometimes you may need to change that to a decimal or a percent. And remember, if you do that, you use division. Part B, what is the probability that she will roll a number less than 7? Well, in this case, we need to go back to our list. How many numbers in our list of possible numbers that show up on that number cube are less than 7? Well, all 6 of them are. So since every one of those numbers, 6 out of 6, it is certain that she will roll a number less than 7, which means the probability is 1 whole, or 100%. C, what is the probability that she will roll a number greater than 6? Well, in this case, none of those 6 numbers are greater than 6, so it is impossible, which means her chances are 0 out of 6, or 0%. Now I'd like for you to take a look at the triad. Answer questions A, B, and C, and then come back and check your answers and work to see if you did them correctly. Check your work for parts A, B, and C. How did you do? Make corrections as needed or come see me for extra help. Then you'll be ready to go on to example 3. Example 3. Use probability to examine fairness. Marisol designed a spinner for a game. The spinner is fair if there is an equal chance for the pointer to land on each number. Is this spinner a fair spinner? Well, first of all, let's cross out the word number in that sentence because when you look at the spinner, do you see any numbers? Nope, we see letters. So if each letter has an equal probability of landing, then we say it's a fair spinner. So when we look at the spinner, the probability of the pointer landing on an A, so we look at the spinner and I see 2 letter A's. So 2 out of the 6 sections, or 1/3 chance of it landing on A, is the probability. The probability, however, of landing on B is only 1 out of 6 because out of those 6 sections, only one of them is labeled with a B. Each of the probabilities for C, D, and E are also 1 out of 6 because, again, there is only one section of each of those 3 letters as well. Since it is more likely that the pointer will land on A than on any of the other numbers, we say this is not a fair spinner. Now you try the spinner in the triad. Explain what you think could make this spinner a fair spinner. So what do you think? If you look at the 10 sections on that spinner, you'll notice that 1, 2, 4 of them are red. 1, 2, 3, 4. 5 of them are blue, and only 1 of them is in gray. So is this a fair spinner? And the answer is no, this is not fair because these colors, red, gray, and blue, do not all have an equal chance of showing up on that spinner. So how could we change the spinner to make it fair? If you look at the spinner, the one section that is labeled in gray, if we were to change that to a red section, then we would have 5 red and 5 blue. Does that make it a fair spinner? Yes, because then red and blue each have an equal chance of showing up on that spinner. So by changing the gray to red, we now can make that a fair spinner.